This video is going to focus on a new factoring technique. So we learned 4 factoring techniques in a previous chapter. We did GCF, we did basic FOIL factor, AC method, and we did difference of squares. So we do have a couple more. This might be one of the first ones that you did not learn in Algebra 1. So this may be a new piece compared to the other ones that were a review. So this next type is called the sum and difference of cubes. We have 2 formulas, one for sum, one for addition, and one for subtraction. You'll notice when I go through them, they're almost identical. You definitely want to make sure you have this formula written in your notes somewhere that you can reference it because it is definitely not something that you should memorize. So here's what sum of cubes is. This is working with 2 terms where both of them are perfect cubes. So your perfect cube numbers, 1 is a perfect cube because it's 1 times 1 times 1. 8 is a perfect cube because it's 2 times 2 times 2. Let's see, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So there are some perfect cubes that you could be familiar with. If not, you can always use your calculator to check. So this formula is specifically going to be what happens when these perfect cubes are being added. How do we factor? So to start these, you're going to start by writing your A and your B value. So your A value is going to be what was cubed to get your first term. So to your first term, what was cubed was just an X. Your B value is going to be what was cubed to get your second term. So in this case, what was cubed to get an 8 would be a 2 because it's 2 times 2 times 2. Once you have that, everything else is just a matter of plugging it into this formula. Again, it's kind of a messy, long formula, but once you're done plugging in the formula, you're done. So you get x plus 2, a plus b is x plus 2. That's going to be your first factor. And then the second factor, x squared minus these two multiplied together. So a times b would just be 2x plus this number squared. So 2 squared is 4. The nice thing about this type of factoring, once you get to this point, it will never factor further. This right here is done. There is no factoring that goes on. In addition to that, when we start talking about solutions and setting this equal to 0, this part will only give you imaginary solutions. It will not have any real solutions that can be found from it. The only real solution that you will get when you solve a perfect cube is from this first factor. So for example, if this was equal to 0, my only solution that I would get, my only intercept that I would get would be -2. So it's kind of a long, messy formula. However, once it's done, unlike some of the other ones that seem like they kind of go on for multiple steps. So our next one, A is 2x, because that's what was cubed to get 8x cubed. And B is 5, because that's what was cubed to get 125. So my formula is a plus b, so 2x plus 5. And then in parentheses, when you square the a, make sure you square the 2 and the x, so you get 4x squared. And then minus these two multiplied together, which is going to be 10x. And then plus the b being squared, so b squared is 25. And again, this may look like something you think, well, maybe it factors further, maybe I should try an AC method. It doesn't. It never will, not even worth trying. So that is your sum of cubes, and it's specifically used when you have 2 cubes that are being added. We also have what's called the difference of 2 cubes, which you're going to notice has very little changes from what we just did. So difference of 2 cubes, the word difference meaning subtraction. Still looking for things that are perfect cubes. You'll notice the formula is so similar. The only difference in this formula, let me kind of highlight the difference here, are the signs. This sign is different and this sign is different. So make sure again that you have this formula in your notes so you can use it as a reference when you're doing Delta math problems on either a homework or a quiz. But notice that your signs are the only thing that changes. So we still write down our A and our B, and it's still what was cubed to get the first term and what was cubed to get the second term. So A would be 3x, because that's what was cubed to get 27x cubed, and B would just be 1. A lot of times I'll have students say, do I need to put -1? You do not, because this formula will take care of it. So once you have your A and your B, then you're just plugging everything into that formula. So it's A minus B, so 3x minus 1, and then A squared, so this whole thing needs to be squared. That's going to be 9x squared, plus, so that's a different sign, these two multiplied together, plus this last value squared. 1 squared is just 1. And as we mentioned in the previous one, you're still going to get only imaginary from this piece. So there will be no x-intercepts coming from there. They will not factor any further. And you will get a real solution from here. That real solution, so again, if this was set equal to 0, that real solution would end up being positive 1/3. Difference of cubes, sum of cubes will only result in one solution when you set it equal to 0 and solve. So here's one that has some u's in it. It doesn't matter what the variable is. Now, there is one thing with this. You might look at this and say, well, 16 is not a perfect cube. There's no number times itself 3 times the 16. Here, what I have to do for this one is I need to take out a GCF. Both of these terms are divisible by 2. They're also both having a u squared in it. So we can bring out the common factor, which leaves us with 8u to the third minus 125. So if you're faced with something that at first glance doesn't end up being a perfect square, doesn't end up being a perfect cube, see if you can take something out. Now, with this piece in parentheses, I can do my A and my B. A is 2u, because that's what was cubed to get 8u cubed, and B is 5. So my formula, so I'm still going to have the 2u squared out front. I'm just going to kind of leave it there. My formula is A minus B, so 2u minus 5. And then in parentheses, a squared, which is 4u squared, plus a times b, 2u times 5 is 10u, so we programmed to do x's, plus 5 squared is 25. So I want to show you that had an extra GCF first, and then you do the perfect cube. So those are your two perfect cube factoring. Again, perfect cube with a sum with an addition, perfect cube with difference with subtraction. Very, very similar formulas, just a very slight change in a couple of their signs, but they both are used in very similar fashion.